we're going to be looking at another GRE math subject test practice test problem. So we have number 47 right here. What's the value of the line integral over a curve C of 5x plus y cubed dx plus 3xy squared plus 8y dy, where C is actually not a curve, but a straight line in the xy plane from 2, 0 to 0, 3. So, first of all, let's actually figure out what the question is asking. So a line integral, just drawing it over here, also known as a contour integral, is essentially when you parametrize an area inside the plane, like this area well, not an area, sorry. When you parametrize a line or a curve, and then you project that onto the surface and ask, what's the area between this curve and the surface? So, how do you actually find it out? Well, often what you're going to have to do is take the surface and reparametrize it given the parametric form of the curve that you're integrating over. So in this case, what's the parametric form of our curve? Well, it's a straight line from 2, 0, which is over here, to 0, 3, which is over here. So it looks like a line with the slope negative 1.5x, and the y-intercept is going to be 3. So that means that if we just defined it like this, this would be our parametric form. Pretty simple. But now, how do we actually take the integral? Well, that's also pretty simple. Finding the integral of this over some curve is actually equivalent to finding the integral from, so when t is equal to a, t being the variable we're parametrizing over, to b of f of x of t, y of t, and by the chain rule, since we're differentiating with respect to x, we've got to bring x prime of t outside. And of course, you can also see a very similar format if you decide to do it with dy instead. So let's calculate it in this specific case. So first, the dx part. What's this? Well, we plug in our parametrizations, and we get the integral. Well, we're integrating from what time to what time? Well, from the point 2, 0 is what? It's t is equal to 2 to the point 0, 3, t is equal to 0, which means we're actually integrating backwards, sort of, which is actually just equal to the negative of integrating normally. So now we just plug in what we have here. We get 5 times t plus, what's this? Negative 1.5t plus 3 cubed. And you know, we also have to multiply that by the derivative of x. You also have to multiply that by the derivative of x dt. Since x is equal to t, that's just 1. So now this is just equal to the negative integral from 0 to 2 of 5t minus the integral from 0 to 2 of, we can take out the 1.5 cubed, make this just t plus 2 cubed dt. And then from there, we can just do a u sub and say that this is equal to 1 over 4t plus 2 to the 4th. So what does this give us? Well, that's pretty obviously just negative 5t squared over 2. So we have this from 0 to 2, and then we have minus 1.5 cubed is equal to 27 over 8 multiplied by 1 over 4 t plus 2 to the 4 from 0 to 2. So then we just plug in the bounds for each one. Plugging in 2 for this one just gives negative 10, and plugging in 0 for this one, well, it gives 0. So you plug in the bounds for this one, and you get what? 1 over 4 times 4 to the 4 is 1 over 4 times 4 to the 4 is 4 cubed, which is 64. And 1 over 4 times 2 to the 4 is just 2 to the 2, which is 4. So you get negative 10 minus 27 over 8 multiplied by 60. Now I can cancel out some factors to just get negative 10. Wait, did that give us? Okay. So you get negative 10 minus 27 over 2 multiplied by 15. So that's already a pretty big number. But now let's do the other side. The integral of 3xy cubed plus 8y. So we have 3t negative 1.5t plus 3 squared plus 8 negative 1.5t plus 3 multiplied by the derivative of y, which with respect to t, which in this case is negative 1.5 dt from 2 to 0 or negative 0 to 2. So you get 1.5 times the integral from 0 to 2 of 3t times negative 1.5t plus 3 squared dt plus 1.5 times from 0 to 2, 8 times minus 1.5t plus 3 dt. So what does this give us at the end? Well, just keep plugging and chucking. So first of all, we figure out that we can put these constants outside to get 4.5 in this case. And in fact, you can also bring out the negative 1.5 squared here to get 9 over 2 multiplied by 1.5 squared is 9 over 4, which actually gives us a constant of 81 over 8 here. And now that we've brought that out, we can reduce this to its base. Hey, wait a second. Oh, crud. I've made a mistake here. That's why it's so big. This would be t minus 2. Unlike 2 or 3 minutes. So now you plug in 2 here, and you get, well, 0. And you plug in 0 here, and you get 4. So that means that what you actually should get is negative 10 plus 27 over 2, which is equal to 7 halves. So what about here? Well, once again, we can take out the 8 over here. That gives 1.5 times 8 is 12. And then we can take off the negative 1.5 here. And negative 1.5 times 12 is negative 18. So here's what we have now. So let's actually get into solving this. We get 81 over 8 times the integral from 0 to 2 of t cubed minus 6t squared plus 9t dt. So let's actually solve this. We get 81 over 8 t to the 4 over 4 minus 6t over 3, 6t to the 3 over 3, which is just 2t cubed, plus 9 over 2t squared.
I have to put it on the appendix too. I understand, I'm very sleepy.
Okay,
I don't know.
1 minute, 1 minute.
I have to put it on.
Okay, so you get 81 over 8. Of course, if you plug in 0, the whole thing goes to 0. So let's just plug in the limit 2. 2 to the 4 over 4 is 4. 2 times t, 2 cubed is 16. Plus 9 over 2t squared is 18. Yeah, okay. So minus 18 times, of course, this once again goes to 0 if you plug in the lower limit. So just plugging in the upper limit gives us 2 minus 4. So what do we get at the end of the day? We get 81 over 8 multiplied by 6 minus 18 multiplied by negative 2. So what is this equal to? This is equal to, you cancel this out, and you get 81 divided by 4 multiplied by 3 plus 36, which, when combined with 7 over 2, gives you the desired answer of D.
Done.